Okay, in this video, I'm going to talk a little bit about the state pattern and how we're going to apply it in our next assignment. Okay, so recall from the video that we have these things called reactive systems that respond to events in the environment. So there are many types of reactive systems. So any program that has a graphical user interface, for example, is reactive. The program is just sitting and waiting for the user to click a particular button or type something in a text box. Any machine that's sort of controlled by a human that is written in software, for example, like a modern car, that's also reactive. So the Tesla is sitting and waiting for the user to turn the wheel or hit the gas or the brake. In my state pattern video, I talked about my garage door opener and my microwave. Those are both reactive systems. We also see like heating and cooling systems, right? So what is your heating and cooling system in your home doing? Well, it's just there's a thermometer and it's waiting for that thermometer to hit a certain threshold, and when it does, the system reacts by either turning on the air conditioner or your heating system. Things like fighter jets, again, are in that same category as Teslas, that they are things that are controlled by humans and written entirely in software. We have our personal assistants, Siri, Alexa, and my favorite, Mrs. Google. They are trained to just sort of sit and wait for us to wake them up and ask them a question. And then we have other systems. A lot of safety equipment, for example, is reactive. So these are systems where they are basically monitoring the environment and waiting for dangerous things to happen so that they can respond to them. So we see these in all kinds of devices, like those Teslas. So modern cars have like collision detection, for example, where they can monitor the environment, and if they believe a collision is going to happen, they can either warn you somehow, or some cars even will step on the brakes or turn the wheel, which is really fascinating. So when you have an event-driven system, state machines are really a great way to model the behavior in them. Okay, so just to recall here, a state represents a period of time when the system reacts to certain events with a particular behavior. And it's possible to have many different states. And then an event is something of interest to the system. Events cause transitions from one state to another. And transitions themselves, they can contain actions. So these are used to perform some activity. They can also have guards, which say that the transition is only going to happen if some particular condition is true. So back in this little state machine here, we have these two states, state 1 and 2. And what this says is if event 1 happens in state 1, we'll make a transition to state 2. And if we're in state 2 and event 3 happens, we'll do this self transition. But as a side effect, we'll also do something. We'll call a function or we'll execute some code. If we're in state 2 and event 2 happens, what this says is we'll check this guard and we'll say only if x is equal to 10 and event 2 happens will we make the transition back to state 1. Okay, so let's imagine we had this problem that we want to write some code that will read a C source code file and basically count the code characters and the comment characters. Okay, so if you are unaware, in the original version of C, there was only one type of comment, the multi-line comment. So this is, we're probably all familiar with the multi-line comment, but even if you wanted to have a single line comment, the way you had to do it was with these, this combination of characters here. Okay, so the goal here is to, again, read a file and count how many characters are code characters and how many are comment characters. So I would like you to think about this problem in such a way that we really want to keep it simple. We're going to open this file and we're going to read one character at a time, but I don't want to have any sort of complicated logic in here. In other words, I want us to open the file and just read it left to right, top to bottom. Okay, we should really only have to go through the content once. And to keep things simple, again, I don't want to have to look forward or look backward in the file. I just want to take a character, feed it into the state machine, move on to the next character, feed that into the state machine, and so on until we get to the end of the file. And when we get to the end of the file, we should have those counts, the number of code characters and the number of comment characters. Okay, so one little caveat here. You can assume that the code you are analyzing is free of syntax errors and compiles. Okay, so that's going to be true in the assignment that I give you as well. Okay, so let's think about possible states for the state machine. So the two obvious ones are, well, we're going to have a code state, in other words, a period of time when we're reading in characters from the file that should be counted as code. And then we will also have this comment state, where again, it's a period of time where, as we're reading in these characters from the file, we should count all of those as comments. Okay. So let's think about possible events next. So again, we're reading characters from a file. So the important characters for this particular problem is, well, the slash and the star. Those are the ones that sort of define where the comments are. And then basically everything else, which I'll just call sort of a generic character. Okay, then a state machine often has these variables that can be updated with the actions that I talked about before. And the possible variables that I could think of that we might be interested in are like just the number of code characters and the number of comment characters. So in my diagrams below, I use slightly shorter names. I think I just use code and comment, but those are supposed to represent the number of characters of each of these two types. Now, these, of course, are going to be held in the context class. So if you recall from the state pattern video, the context class is basically designed to hold data, and really no data should be in the state classes. So you can assume that these variables will be initialized to 0, and then every time we encounter a code character, we'll increase one counter. Whenever we encounter a comment character, we'll increase the other. Okay, so here we have the sort of beginning of this state machine. So this basically says we're going to start in this state called the code state. And then there are really three things that could happen in every one of the states. So we could get a character, and what's going to happen in that particular case, if we're in the code state and we're reading these characters one at a time, in the code state, a character should increase the code counter by 1. And you'll see the self-transitions are really good for sort of assigning actions while not really changing to a different state. It does give us a way to add this little bit of functionality when a character happens in the code state. The other thing that could happen is we could have a star. So the star is used for all kinds of things like multiplication and creating pointers and dereferencing pointers. Okay, but if that is in the pure code state, we just want to count that as a code character. Now the interesting event in the code state is the slash. So the slash could mean one of two things. So I have an example down here. So the slash could be just the straight division. Maybe we're dividing two numbers. And again, we're sort of doing this one character at a time. We don't really want to have to look ahead. And the other thing that could happen is we could be actually starting a comment with this slash here. Okay, so at this point, we don't really know how to count that slash. Okay, we're going to have to delay that counting until later. Okay, so now that we have this new state, which I call the slash state, okay, again, there are three possible things that could happen in this state. We could encounter a character. Okay, so what this means is the only way we got to the slash state is that we encountered a slash in the code state. But if the very next thing is a character, well, then we know for sure it's not actually going to generate a comment. This This would be in the case where we maybe have that division, 10 divided by 3. Okay, and if that happens, we want to basically count the slash that got us to this state and this new character. So here I'm saying code add an equals 2 basically means add 2 to the code count. And then take us right back to the code state. The other thing that can happen is a star. So if we encounter a slash immediately followed by a star, well, we know that's the beginning of a comment. And then we could count those two characters, the slash and the star, as comment characters. And that would cause a transition into the comment state. So you might notice, well, we're missing, well, what happens if we have a slash in the slash state? And it turns out, because of what I said before, all the code that we ever will analyze must be able to be compiled. Well, we can't, it's not really legal syntax to have two slashes next to each other in a C program. Okay, so we can just ignore that because it should not happen. Okay, next, so I introduced this comment state. And again, there's three things that can happen. We have our three possible events. We could encounter a character in the comment state, in which case we'll just count that as an additional comment character. We could encounter a slash, and again, we'll count that as a comment. Or the interesting thing is we could encounter a star. And the star, of course, is the beginning part of the ending multi-line comment. But again, we don't really know for sure that the comment is ending until we see the next character. So what we'll do is we will definitely count that as a comment character, but then we will transition into this new state called the star state. Okay, and then to sort of wrap this state machine up here, if we think about the star state, there's really three things that could happen. We could encounter a character. So that means we sort of had a star and then some other non-slash character. Then we know for sure we're not ending the comment there, and we would just transition back to comment and increase that counter. We could encounter another star, right? So here's an example of, for some reason the user might put in this type of comment. And if that's the case, again, we want to increase the comment count, but just stay in the star state, because if we do ever encounter that final slash, then we'll want to go back to the code state. And that's the last possible action here. If we get a slash in the star state, we want to increase our comment count, but then switch back to the code state. And all code from that point will be counted as either all text that comes in at that point will either be code or possibly the start of another comment. Okay, so that was an example of a problem that maybe didn't outwardly seem like it was state-based, but it actually, I think, is a good solution to this problem, to generate the state machine to solve that problem. Now, your next assignment is basically to do the exact same thing, except instead of using C comments, we're going to use Javadoc comments. Okay, so recall that in Java there are three types of comments: the single line comment, which starts with two slashes, the multi-line comment, which is the same as in the first example, and then Java also has this thing called a Javadoc comment, which is anything that starts with a slash and two stars and ends with a star and a slash. Okay, so the first step is, and this is by far the most important step for this whole assignment, is just create a new state machine that's going to be similar to the one above, but not exactly the same. So it has to deal with single line comments and Javadoc comments as well. The next part of the assignment is basically just a translation. So it's pretty mechanical to take a state machine and turn it into the state pattern. So that's what that whole video is about. That I have a playback showing how to do that. And I won't rehash those details right here. So a couple things: you must use the state pattern. Okay, so there might be other ways to count code and comment characters, but I want you to use the state pattern. And you must handle the file one character at a time. In other words, I don't want a whole bunch of different loops and complicated ifs and booleans. We really should just be grabbing the next character and feeding it into our state machine. So don't look forward or backward. So just a couple things. The state classes should not have any data. Remember, the context class is responsible for holding data, and the context class is passed into all of the state classes when an event is handled. The context class should always hold a reference to the current state. Okay, and again, check the video for this reference to the current state. I would suggest you use singletons for your state classes. That makes changing state a little bit easier. And then one other thing I didn't really address in the problem above is that in C code and in Java code, we have strings. And strings might have comment characters in them that we don't really want to treat as comments. So for example, look at this code here. This is declaring a Java string, but inside the string, it looks like that's a comment, but that really shouldn't be counted as a comment. It should be counted as code. So you're going to have to deal with that. Another thing that strings can have are these escaped double quotes. Okay. So here's another string, but here we have these backslash quote combinations. And again, that's how we get a quote inside a string. Okay, so your program has to handle that as well. Okay, so now the characters of interest have expanded a little bit. We still have our star and our slash, and we have our general character, or everything else. But now we also care about new lines, we care about quotes, and because of that escaped character, we care about the backslash as well. Okay, another interesting thing, you may encounter this character \r, which is, it's called a carriage return character. So you can ignore it for this program. On Windows machines, for historical reasons, a new line is actually two characters. It's a carriage return and what's called a line feed. And on Unix and Macs, a new line is really just the new line character. Okay, so if you do happen to encounter these carriage returns, you can just sort of ignore them. You don't have to feed those into your state machine. Another thing is I don't want you to count new lines as code or comments. In other words, new lines are not visible, so don't increase any counters when you encounter a new line. But the new lines might cause transitions from one state to another. And then finally, I want you to build a GUI that allows a user to select a .java file, does the analysis, and then displays the results in a clean and professional looking GUI. Okay, so that wraps up my brief discussion of this code counter program. And again, I think the hard part or the interesting part is not writing the code, it's actually coming up with the state machine.